This is the Day 8 challenge of Advent of Code 2025, and this challenge is called Playground. Equipped with a new understanding of teleporter maintenance, you confidently step onto the repaired teleporter pad. You materialize on an unfamiliar teleporter pad. Find yourself in a vast underground space which contains a giant playground. Across the playground, a group of elves are working on setting up an ambitious Christmas decoration project. Through careful rigging, they have suspended a large number of small electrical junction boxes. The plan is to connect the junction boxes with long strings of lights. Most of the junction boxes don't provide electricity. However, when two junction boxes are connected by a string of lights, electricity can pass between those two junction boxes. The elves are trying to figure out which junction boxes to connect, so that electricity can reach every junction box. They even have a list of all of the junction boxes' positions in 3D space, the puzzle input. So they have all these positions, and it's X, Y, Z. To save on string lights, the elves would like to focus on connecting pairs of junction boxes that are as close together as possible, according to straight line distance. In this example, the two junction boxes which are closest together are 162, 817, 812, and this one. By connecting these two junction boxes together, because electricity can flow between them, they could become part of the same circuit. After connecting them, there is a single circuit which contains two junction boxes, and the remaining 18 junction boxes remain in their own individual circuits. Now, the two junction boxes which are closest together but aren't already directly connected are these two. After connecting them, since 162.817.812 is already connected to another junction box, there is now a single circuit which contains 3 junction boxes, and an additional 17 which contain 1 junction box each. The next 2 junction boxes to connect are those. Then there's a circuit containing 3 junction boxes, a circuit containing 2 junction boxes, and 15 which aren't connected. The next 2 closest are these 2. Because these 2 are already in the same circuit, nothing happens. This process continues for a while. The elves are concerned that they don't have enough extension cables for all these circuits. They would like to know how big the circuits will be. After making the 10 shortest connections, there are 11 circuits. 1 circuit which contains 5 junction boxes, 1 which contains 4, then 2 which contain 2, and 7 which each contain a single junction box. Multiplying together the size of the 3 largest circuits, 5, 4, and then 2, it's 40. So your list contains many junction boxes. Connect together the 1000 pairs of junction boxes which are closest together. Afterwards, what do you get if you multiply them together? Okay, I am not 100% sure how to do this one, but we can try to figure it out. So I suppose we should probably look at this. We're doing math. So need to first record these. We then let's say about the when it's joined together. So connect as close as possible by connecting these 2 junction boxes together. So the 2 which are close together but aren't already directly connected are these. For connecting them, it's already connected to another junction box. There's now a single circuit which connects to 3. Because these 2 are the same, nothing happens. Don't know if it says anything about if you've got like 2 groups and then they connect together. Okay, so let's probably need to take this a bit slower. So let's create a struct for the point in 3D. So public struct point 3D, and we'll have public int x, public int y, public int z, and public point 3D. We'll take int x, int y, int z, and we just do x equals x, y equals y, and z equals z. So this will represent just one of these lines. So I guess let's start off with creating the list of, what would you call these? These represent the junction boxes, or are they just coordinates? Position, we'll do positions. Var positions is equal to list of point 3D. Then we'll do, I need to select as new. We'll do for each var line in input. And how are these? Okay, var parts is equal to line dot split on the comma. And we'll do int x is equal to int dot pass parts 0. And we do y z 1 2, then positions dot add new XYZ. Okay, so how does this work with... So we need to record the distance. So this is meant to be 3 dimensions. Okay, so from looking at this, you have... This is all about the coordinates. So for 3 coordinates, you have... So it would be like X, Y, Z. And then of... That's 1 coordinate, then X, Y, Z of another. So do minus on those 2 and square it. Minus that and square, minus that square. Add them together. You do square root of it. And that's what the distance between P and Q is. Okay, so I'm going to create another struct, and we'll call it distance. We'll have a public int for distance. Actually, based on that math, we should do double, because it's going to be decimal points and stuff. And we'll store the index within this list for it, so we can represent, we use that as like the way to represent the shape. So public int, let's do index P, and public int index Q, just to make it obvious. Those letters representing this, and that is all that we really need. Just gonna go through and do this. I should make this capitalized. Okay, so we've got that. Why? Yeah, I need to. Okay. Let's do point distance. We've got that, and now we want to actually build up the distances between them. So let's do var point distances is equal to new list of point distance, and we will basically go through all the points and then perform the distance calculation on it. So we'll do for int I is equal to 0, I is less than positions dot count minus 1. Then we'll do I plus plus. Inside of here we'll do for int j is equal to 0. J, actually this should be equal to I plus 1. J is less than positions dot count j plus plus. So we'll go up here for what naming are they using? P is equal to positions I, and Q is equal to positions j. And now it's a matter of doing this. See, can I copy this? So I've got it as reference. Yeah, that doesn't really work. We'll do double. Okay, double distance x is equal to p dot x minus q dot x, and then same for y, z, like so. And then for the actual distance, that is so square root, so math dot square root, and we may as well just do this calculation. So we don't need to do power t, just do dx times dx plus dy times dy plus dz times dz. Sure, I did capital Z there, so change that. And so you minus these from each other, q from p, and do the power of 2, which is what we've done by multiplying like this. You add them together, and then you do square root. So with that, we should be able to add to our point distances dot add new, and that will be just set up a distance. Then it'll be I j, so doing distance index of p, index of q, and oh, my mistake, I need to change it to double there. Okay, so with this, we should have all of the distances now. But what we actually, okay, so we've got that. What we now need to do is needs to be sorted now. So point distances dot sort, and d1, d2, they are being sorted by d1 dot distance dot compare to d2 dot distance. So that should be sorted from lowest to highest now. And okay, so we've got them sorted. We now need to handle the actual grouping of them. So I guess think about it. Let's do int total connections, is it? So I wanted 1,000 for one, and then pairs. So int total pairs. And for the test data, it will use 10. Where is it at? Yeah, so it had 10 for that. So start off with 10 and then change to 1,000 for the actual one. Okay, so I've been sitting here thinking about how to actually do the circuit part of this for a while, and I think I might have an idea of how to do it. So initially, every junction box will be in its own circuit. So an easy way to start off with that is by creating circuits, and we'll create this as a list of hash sets. So the hash sets will be for storing the indexes of the boxes. Then the list will be all the circuits of it. So new list of hash set int. So we have this. We will then initialize it with for int I is equal to 0, I is less than. This is positions.count. Then I plus plus. We'll then do circuits.add, and we're creating a new hash set which contains only the index of the junction box which we're currently looking at. So we initialize this hash set with just I. Okay, so we've now got our circuits. So what we now need to do is go through our distances and join them together. So we're using total pairs as the variable for how many connections we make. So for I is equal to 0, I is less than total pairs, then I plus plus. So we'll retrieve the point distance we're using. So that'll be equal to point distances I. We now want to grab the index of, so int p index is equal to pd dot index p, and int q index, which is equal to pd dot index q. Okay, so we've got our indexes. We now want to find out what circuit p and q are a part of. Okay, so we need to initialize hash set int circuit p, make that null, and then same thing for circuit q. Now we need to go through every single circuit, fast circuit in circuits, and we need to find the circuit that our p and q are a part of. So if circuit.contains p index, then circuit p is equal to circuit, and we do the same thing for q index and circuit q. If we've gone through and we've retrieved both circuits, so if circuit p is not null and circuit q is not null, we then no longer need to keep searching. So we do this. What we then need to do is, outside of this, we need to join the connections together. So circuit p dot union with circuit q. So this modifies circuit p, so that is all the elements of circuit q. So we do that. So now circuit p has everything that's needed. From the original circuits, we can remove circuit q. So once we've done this, it should all be, we've figured out the connections, and then it's a matter of figuring out the sizes. Actually, what is, so you connect, give 1,000 pairs. What do you get if you multiply over the size of 3 lines? Okay. So we then create a list of int sizes equals new list of int. We then need to, for each fast circuit in circuits, we don't actually need the values anymore, we just need the size of them. So it's just sizes dot add circuit dot length or count for the count. Then just need to do sizes dot sort, and then that, because that goes low to high, but then need to do sizes dot reverse. And with that int output little one, we then do for int I is equal to 0, I is less than 3, I plus plus, then do sizes I, actually we'll go back to here, output times equals sizes. Then we print out sizes. Okay, so I've done this without running it, so it'll be interesting to see how this works. Let's run it, find out. Okay, possible null reference. That's for this. If circuit P, we'll grab this. Just do that. So let's try running that again. We got 20. Okay, so that's not correct, but what we should do to see is print out this sizes and then string dot join will comma separate it with sizes. Okay, I should actually do that under here when we reverse it. So 5, 2, 2. So why would it come out as 20? Output. Let's just go here. This value we're using, and then the output number. Okay, we seem to be messing up somewhere. So we've got 5, 2, 2 instead of 5, 4. Actually, no, it should be 5, 4, 2 instead of 5, 2, 2. Okay, what do we have recorded section? I'm out of curiosity. If we make this 11, what happens? Stays the same, didn't change. Let's go to 20 just to see what happens. Okay, something's definitely broken somewhere. Somewhere went down to 3. I want to do 1, see what happens. Got 2. Okay, I'll get rid of this print because you know that math's working. We'll keep that one, get rid of this. Then let's go to 2 iterations. What did it say here? So these two connect, and these ones are closest, which makes it 3. So it is working, that part. So that'll be 3, 2, 15, whichever one. Okay, so there's currently 17 ones. So we make this a 3, 3, 2. So at this point it's still working. Okay, so let's see what happens. If we do 4, it's saying nothing should happen. It should be the exact same. Okay, so that didn't work. Where did I go wrong with that? Oh, I need to, with this, I need to make sure that they are different. And circuit P does not equal circuit Q. So if I run this again, now it should go back to 3, 1. Okay, good, it did. So if I bring this back to 10, 40, there we go. Okay, so let's remove these prints and change it to 1000 and grab the puzzle input here and place it here. Now let's run and see what we get. 63920. So go back here, submit, and we got the right answer. So now on to part 2. The elves are right. They definitely don't have enough extension cables. You'll need to keep connecting junction boxes together with the all in one large circuit. Continuing the example above, first connection which causes all of the junction boxes to form a single circuit, so between the junction boxes at this one and this one. The elves need to know how far those junction boxes are from the wall so they can pick the right extension cable. So multiplying the x coordinates gets this number. So continue connecting the closest unconnected pairs of junction boxes together until they're all in the same circuit. What do you get if you multiply together? Okay, that seems to be much easier than part 1. So if we go here, part 1, and let's change how this works. So we are no longer doing this, and we'll do while circuits.count is greater than 1. Actually, no, we can put that in the for loop, can't we? For I equals 0, circuits count is greater than 1, I plus plus plus. Yeah, you can do that. So this seems to all be correct still. Let's somewhere record the last point direction. All these circuits, we've got this. Var final point distance. Let's just do equals. Let's just make this equal point distance as 0, just as initializer. So we do this, and we'll go here and do final point distance is equal to PD. So when we get to here, we can grab this. So it'll be final point distance, and this, or we'll just name this to final index, final Q index. Then we do output is equal to final P dot X. Alright, I need to actually retrieve the positions. So we do point 3D, final P is equal to positions, final P index, and same thing here, final Q index. And output should be this times this of X. So let's switch over to test input and run it and see what we get. Got an error, index was out of range. So line 88. Alright, that's for part 1. So let's run it again. Okay, I forgot to add output to the right line. Try again. 252. Okay, that seems to be correct. So we'll switch back to real input, change this to actual total pairs so I don't get the error, and run it again. And we've got this number. So let's enter it in and submit. And that is day 8 complete. If you like this video, make sure to like and subscribe.